Here's integrated 3. This is problem 9-46, and it says the measure of angle ROS in triangle ROS below is 60. So I drew it, I don't know if it's any better, but so the circle is, or sorry, the angle ROS would be ROS. So I labeled it as 60. And it says the curved arrow represents the rotation of OR. So this OR is a radius, isn't it? The rotation of OR beginning from the positive x-axis. Through how many degrees has OR rotated? Well, so OR, I wish this was the exact size of OR, but OR is the radius, okay? And so they're saying beginning from the positive x-axis. We always open up our radiuses from the positive x-axis. So they're go from the origin to the edge of the curve. My stick is too long, but I don't want to break it right now. So I'm going to open up this angle counterclockwise until it lands on the radius OR. Okay, so, and I'm going through some angle measurements. I'm going through, well, that's about 90 degrees, right? And I keep going, opening it up. That's 180 degrees. Keep opening it up. That's 270 degrees. And if I keep going all the way around, that's 360. But the segment OR is actually, it's right here. And so I know from the positive x-axis all the way around, it'd be 90, 180, 270, all the way, to where it started would be 360. But so that would be 360, but I have to back up by 60 degrees to get it to land here. So it's basically 360 minus 60. So it's 360 minus 60 degrees. And that's why you probably saw in the answer key is 300 degrees. So that was the answer to letter A. Letter B says if OR equals 1, so this radius OR, if it equals 1, what are the exact lengths of OS, so OS, and SR? Okay, what are they? Well, my picture's not drawn to scale, but I am going to use similar triangles to find the exact lengths. And some of you might know, you might already remember that you can use, now that we know that this radius is 1, you can use cosine and sine, because we learned that, about the Screamer ride. Cosine will give you this OS, and sine will give you SR. And so you could use that in your calculator, but they want the exact measurements. So I'm just going to use some special triangles. So because this is 60 degrees, I know this is 90 and this has to be 30. So I've got a 30, 60, 90. If you remember this from Integrated 2 or some other class, the side across from 30 is always like 1 or 1x. The hypotenuse is always twice as long as the short side. And the long leg is always root 3 times the short leg. So I've drawn, hopefully I labeled it correctly. I guess this would be O right here. I've drawn in our similar triangle, and I labeled the hypotenuse 1. So now I can solve for x. X, by the way, this is kind of upside down. I don't know if you can do that in your mind, but this thing, I took it and like twisted it around. So So this is actually going to be half. It's going to be 1/2. And if that's not obvious to you that this triangle is half as big as this triangle, you could go 2x equals 1, and you could just solve for x. And so that is part of our answer. So I'm going to bubble that in. But let's keep going since we have the picture here. We know that the longer side, the longer leg of a special right triangle, a 30, 60, 90 special right triangle, is going to be whatever the short leg was times root 3. So our short leg's 1/2, so it's going to be 1/2 times root 3. Well, 1/2 times root 3, I can just write it as root 3 over 2. So that gives me that, what was the exact question? OS is 1/2, and the other one they wanted was SR. So these are the answers to letter B. And then letter C says, what are the exact coordinates of point R? Well, we would need the x coordinate and the y coordinate. Do you see that it would just be this length? It's going to be negative though, isn't it? So we better not forget to put a negative sign on this. So this length right here is just OS, and we just found it. So it's 1/2. This length right here, we did just find it. It's root 3 over 2, because that's RS. We just have our triangle flipped. Sorry, we just have our triangle flipped upside down. That's RS. So that is root 3 over 2, but since I'm in the coordinate plane, I know that the y value here, that's going to be negative. That's a square root sign. And I think that's all I have for you. That has answered the question.